Okay, so this quick video is just going to run through the notes and explain how we got the answers for the examples that we got. So the first theorem that we learn is that if a line is tangent to a circle, then it's perpendicular to the radius. And then the converse of that would take those statements and switch them, and it would say if a line is perpendicular to a circle's radius, then it is a tangent line. So for the example, so the first one is using the theorem like normal. It says that this is a tangent line to circle O. And based off of what we just learned, it says if a line is tangent, then it's perpendicular to the radius. Perpendicular means that it makes 90 degrees. Okay, so we've got a 90-degree angle right here. The problem is asking us to solve for this angle x. This is a triangle. So now that we have two angles out of that triangle, we know that angles should add up to 180. So we can add 90 plus 38. That gives me 128. And then 180 minus 128 gives me that angle x should be 52 degrees. Okay. All right, the next one is asking, is segment AB a tangent of circle C? So this has to do with the converse. So if it's a tangent, then that means that this would be a right angle. And if that's a right angle, then that means that this would be a right triangle, and right triangles have to follow the Pythagorean theorem. So what this question is really asking is, does a squared plus b squared equal c squared? If it does, then yes, it's a tangent. If the answer is no, then it's not a tangent. So the first thing you need to calculate is your a squared plus b squared. So if I type that in, okay, 20 squared plus 44 squared is 2,336. Okay, then we do c squared. So if I type in 52 squared, that's 2704. These are not equal, so no, this is not a tangent line. All right, on the next example, we have another one, same kind of problem. Is segment LM a tangent of circle M? So it's asking, is this a right angle? If it's a right angle, then the a squared plus b squared will equal the c squared. So if we do our a squared plus b squared, 7 squared plus 24 squared. Okay, that gives me 625. And then c squared would be 25 squared. So if you do that, we get 625. These are the same, so yes, it is a tangent. Yes. Okay, the last theorem is the tangent segments theorem. It says that if you have two tangent lines, so remember a tangent is outside of the circle, it intersects the circle in one place. So in this picture, this line right here is a tangent, and this line right here is a tangent. And notice that they both intersect each other out here at point B. When that happens, that means that this line right here is the same length as this line. So these are congruent. Okay? So how we can use that is with problems like this. It says find the perimeter of the circumscribed triangle. Circumscribed just means that the outside edges are all tangents. So this is telling you that all of these outside pieces are tangent lines. So all of the tangents that intersect in a place outside of the circle are going to be congruent to each other. So what that means is that this piece right here is going to be the same as that piece. Okay, I'll get my pink. This piece right here, which is 3 centimeters, will be the same as this piece. And then this piece right here, which is 5, will be the same as that piece. So adding that to my picture, if this is 3, this is 3. If this is 4, this is 4. And then if this is 5, this is 5. Perimeter just means to add up all of the edges, so let's add them up. 5 plus 5, 4 plus 4, 3 plus 3. Add that together in your calculator and you'll get a total of 24. So the perimeter of this triangle is 24. Okay. We're not going to bother with example 2 today. It's just a little bit complex. We can talk about it at a later time. But for now, that's what we're learning today. So please ask me, talk to me if you have questions after watching this video.